Hi, my name is Anthony Roach. I'm a product manager at MarkLogic. Today, myself and my colleagues are going to talk to you about machine learning. So we're not in school right now, so this is not a math class. We'll keep the math to a minimum. Talk about how machine learning can actually help your business. So when I think about machine learning in this context, I think about Michelangelo. So Michelangelo believed that his sculpture David was trapped inside the model, in the marble, and all he needed to do was use his special tools to chip away and find it. Think about the same thing with machine learning. There is information that is trapped in your data, and you just need a special tool like machine learning to pull this out. Let me do a quick room poll here and see where people are on their machine learning journey. So from a scale from 1 to 5, 1, you know a little bit about machine learning. Maybe you've been targeted by a Facebook ad. 3, you are very confident, you understand all about it. Maybe you fall asleep in your Tesla on the way to work. And 5, you consider yourself a real data scientist. You're a hands-on keyboard machine learning person. 1, 3, or 5? 4s. Good. Okay, good. So we have a good mix of people here, and we'll start with an overview of the space just for people who are less familiar. But I would like everybody to understand some of the general concepts before we move forward. We'll talk about the data scientist, what we're doing in MarkLogic to enable machine learning in the database and in the data hub. My colleagues will introduce themselves when they do a couple demos for us, and then we'll talk about what's coming up in the future. So this is an overview of the space. Artificial intelligence is really ambiguous. I don't use it as a term. It really just describes the results of a technique as opposed to a technique itself. Machine learning is a little bit more specific. It's talking about systems that can change their behavior as they're executed, and they do that by statistical methods. And deep learning is even more specific than that, a subset of machine learning. It is where those systems actually create artificial neural networks to do the work. One thing important to know about this is none of this is really new. Gradient descent is a very popular mathematical way of optimizing these models. That was actually created in 1847 by this guy. A lot of those neural networks that run the Teslas and do a lot of the innovative things today were created in the 90s and the early 2000s. So this is not something that's really new. We haven't talked about what it is yet, though. Let's get into that. So machine learning is essentially pattern recognition. So in all that data that you have, there are patterns and relationships between attributes that can be uncovered, and you can use them to do a lot of interesting things. A machine learning model is just a mathematical representation of those relationships. Think of it as an objective function. You give it some input, and it will give you some output. Most commonly, what that output is classification or a prediction. Now, any of your entities in your business can be analyzed through machine learning. So you think about entities you might have, like a person or a trade or a chemical formula. They all have attributes, call them features in machine learning. And the relationships between those features is what the model finds and creates that objective function for you. So when it does prediction, changes to one of those features or attributes could predict a future state of that entity. For classification, if you introduce a brand new entity to your system, from what it's learned by looking at historical data, it can classify that new entity based on its features. A lot of this can be done with rules, and when the size of the feature space is small, that means there's few attributes, you can actually create a pretty good and pretty accurate rules-based system. The problem is when those attributes create a really high dimensional space, or if the relationships between them are really complicated, it's very difficult to create an accurate rules-based system. And very often the machine learning model will be more accurate. The other thing that's great about it is accuracy can actually improve. So when you retrain your model with new data, it reinforces certain relationships, and it can actually get better over time. Again, none of this is really new. Businesses have obviously always wanted to do this and understand their customers better. And as I said, the math is not new, so why is this becoming a big deal right now? First of all, it's the data. You need a lot of data to train these systems, and enterprises are creating more and more data all the time. The reason why Facebook and Google and AWS is advancing a lot in this space is just because the amount of data they have to look at. Data integration is also really important because the relationships between the features are not easy to detect and very common. Features for the same entity could be spread across different silos in your business. You may not be able to find them until you integrate that data. So that 360-degree view that your customer rep uses to service the customer is the same 360-degree view of the entity that your machine learning model needs to train. Second, frameworks. So all these machine learning frameworks allow you to productionalize the math and actually create models. They are all free, and there's a huge momentum behind them from the community. So they're always getting better and getting faster and more accurate. Now, in order to do this work, to crunch this data, you need a lot of processing power. Essentially, what these models do is turn all of those attributes into vectors, into numbers, and perform a lot of matrix math against them to reduce error and to figure out what those relationships are. Traditional CPUs are really not that good at it. A very small amount of the transistors in your CPU is dedicated just to doing math. And even if you have a really big machine with 64 or 128 CPUs and then a cluster of 10s or 20 of those, that's not really a lot of computing power when we're talking about doing this kind of math. Any video gamers in the audience? So we can thank Grand Theft Auto and Doom and others for really pushing this because it made companies like NVIDIA spend a lot of time creating more and more powerful graphics processors and making them much cheaper. And what was found by happenstance afterwards is the same kind of highly parallel matrix math problems that are required to do graphics processing are actually required for machine learning. So that's where GPUs come into the picture. Now excuse this really weird x-axis. This is from NVIDIA, I didn't create this. So this is relative performance based on time. So that means a longer bar is better, a shorter time, which makes not too much sense at all. But the CPU-only server took 711 hours to execute this training. That's about a month to execute. The GPU server took 18 hours, and then this DGX-1 with Tesla did the exact same process in 7.4 hours. What that is a machine learning appliance that NVIDIA sells, essentially a big rack-mounted box that's filled with video cards. That's what it looks like right there. This laptop that we're working on right now is a fairly good developer's machine. I think it has 8 CPU cores, but its video card has about 900 cores. This machine learning appliance here has about 20 CPU cores, but it has 25,000 GPU cores. And that's why it's able to do work like that. Of course, those of you in the cloud, Amazon and Azure offer GPU instances that you can start up. Here's an example of some of the ones you can get from Amazon. They have 1,500 cores each. So that kind of describes the space and why GPUs are important. Let's talk a little bit about the data scientists. I think I saw a few people who had 5s here, so there are some data scientists in the audience. Justin actually mentioned this when he was talking from the main stage today, that data scientists really only spend about 20% of their time on analysis, and then 80% of that wrangling data. The more you know about what a data scientist is actually supposed to be doing, the more you realize that that is a challenge and something that is leading to a lot of inefficiency. I went on the Google machine and did a search to find out what data scientist was, because there's a lot of different descriptions here, and I found some ones that I love. Yeah. So the last one, I like the first one obviously, but the last one is actually really telling. So in my previous life, I worked at Kaiser, a health insurance company, in their pricing department. And they had a lot of people who worked there who had degrees in actuarial science or degrees in multivariate statistics. But one thing that was true about all of them, they were all amazing SAS programmers. You know, they were not called data scientists, but you know, essentially that is what they were. That's what they did. Their goal was to look through all of this data that Kaiser was generating, determine what those relationships are, you know, find out and you know, execute predictions to figure out, you know, where the business is going, where they need to spend more money or spend less. You know, that was their goal, and that's what they should be spending most of their time doing. But as you can see from this, they actually spend a very little. They spend like 30 hours a week doing data wrangling. There's actually a much better definition of data wrangling here. The process of transforming and mapping data from one raw form into another just to make it useful for some downstream purpose, data science in this case. Data wrangling is data curation. We're at MarkLogic World. You're going to see this all the time. You're going to see it one more time today. Probably see it when we're playing ping pong too. So, you know, finding the right data, harmonizing it, deduplicating it through mastering, enriching it, all of this is important to data science. This is the core of what the Data Hub framework does. Explainability is also very important in the machine learning world. You are not writing rules like you do in a traditional system. It's the data that's essentially writing the rules for you. That's what training does. You know, so being able to explain what the data is, where it came from, how it was transformed, that's even more important than it is for normal analytics, because that's not only describing what's happening to the data, but that's describing how the code that's in your model was written. So that's where we are. That's why machine learning is important, and that's why data curation is really important. Everybody here has been waiting for this slide, I'm sure, because you want to know what's coming out in MarkLogic 10. So Justin talked about this very briefly, and I'll go into a little bit more detail now. The point of this integration is so you can execute these models close to the data, you know, parallel across the cluster, and under the same security umbrella that is true for everything that's happening in MarkLogic. So how did we do that? Anybody familiar with CNTK? You didn't count. Yeah, so CNTK is Microsoft's cognitive toolkit. It is essentially a machine learning library that Microsoft had used to create a lot of their own products. They used it to create Skype and Bing, and they had a product called HoloLens. It's a VR environment. And then they released that on GitHub as a project that other people can use, a deep learning library. So we've taken that library, we've embedded it into MarkLogic and exposed all its functions as JavaScript and XQuery built-ins. So you can use these with all of your current MarkLogic applications. CNTK is great. It's enterprise grade. They spent a lot of time working on reducing communication costs. So it works very well in a clustered environment. Multiple machines in a large cluster, multiple GPUs, which is why we also embedded NVIDIA's CUDA libraries in MarkLogic. So these are libraries created by CUDA that allows you to offload some of those parallel math problems from your CPU to your GPU. So if you have one or multiple or a huge deep learning engine and you want to offload the processing for machine learning to those, then you do that through CUDA. Two notes I make here. Obviously, CUDA is NVIDIA's product, so it only works with NVIDIA cards. That's really not an issue for anybody. NVIDIA owns 85+% of the GPU market, so you might have a harder time finding a non-NVIDIA GPU. And it's initially leveraged in MarkLogic only for these CNTK built-ins. So you're not going to have GPU accelerated sorts or GPU accelerated backups or anything like that in the initial versions. It's really just for these machine learning libraries. Another great feature that comes with CNTK is it supports ONNX, the Open Neural Network Exchange format. So this is an open format that was created by Microsoft and some of its partners to allow you to export models from one framework or toolkit and use them in another one. So if you had a model that you created in TensorFlow or PyTorch, you can export it to the ONNX format, load it into MarkLogic, and it will work there. It's great. It prevents ecosystem lock-in. It allows the data scientists to continue to use what they've created already. There's actually another project called the ONNX Zoo, where you can go and they have pre-trained models that you can download in the ONNX format and lose them in any of those, in any of your environments. It supports all of the most popular frameworks, and has converters and runtime compilers and visualizers. So it's very full-featured, and it has a lot of support, so it's easy to move models between different environments. So what are we doing with this? So Justin mentioned this as well, and I'll touch on them again just so we can reinforce that. By embedding machine learning into our products, we can actually bring some more intelligence to the database, the infrastructure, and the data hub itself. Smarter mastering is now looking at all of those attributes of your entities and going beyond what you can do with your rules-based system and augmenting that with a model that can actually do more prediction and classification and determine if there should be matches or not. The autonomous elasticity, instead of looking at your data, now our model is actually looking in at the data that MarkLogic is creating, determining when there are bursting or scaling events and being able to predict those and allowing the infrastructure to react better to changes in workload. Same with predictive query optimization, not looking at the infrastructure more, it's actually looking at execution query plans that are created when you execute queries against the database, making changes there and predicting different patterns in your workload. Proactive curation and governance. Now again, you're looking at your data, using these models to identify PII or make mastering recommendations or modeling. That's again being able to run your data hub a little bit better. And of course, roll your own. So if you have data scientists, these are all built-ins that you can use now and actually embed machine learning into the fabric of your MarkLogic application. So this is what's coming, and this is what we're working on right now. We have some customers who are very disruptive, and they're already out there, working with machine learning. Before MarkLogic 10, the only way to do that was to take the data that's in MarkLogic, export it to some external machine learning library, and then, if required, pump the results back in. I call this the fast, secure pipe method. And I'm going to introduce our first two speakers, Imran and Bijou, to come up and talk a little bit about a use case using Spark.
Hi, everybody. Can you hear me? Hello? You can hear me? Yeah. Awesome. So this is what I'm talking about right now is MarkLogic 9. It's doable today. People can do it very easily. And so without further ado, let's talk a little bit about, again, summarizing what the world looks like in MarkLogic 9. So in MarkLogic 9, the operational data hub does a really good job of getting your data, harmonizing it, curating it, data wrangling, per se, and then it provides a lot of different views of it, right? It gives you document views, graph views, geospatial views, rows and column views, right? And then typically people take that and build fast pipes out of MarkLogic into an AI world and do the AI computing, and then send the relevant results or learned results back into MarkLogic, where you can operationalize them and run them in real time, right? So there's a couple of really interesting things here, even with this set of models that MarkLogic brings a lot to the table with. And one of the big things is, in a past life, I was doing clinical analytics, running through basically teaching computers medicine, essentially. And if I had 10 million patients in my system, that didn't mean I had 10 million data points. I probably had in someplace close to 1 billion or 10 billion data points that I had to deal with. Now, when I'm doing machine learning, I'm typically not using that whole data set. I'm typically using a very small subset of the data set that the machine is trying to find signal from in that system. And an example might be, hey, I only want to do machine learning on patients that have been discharged from the hospital and went back to the hospital within 30 days because CMS slaps me on the wrist quite hard when I do that. They don't pay me, right? So out of that sort of 10 billion data points, I really might only have 1 million data points that are relevant to the machine learning task at hand. Now, the naive way to do it, which we did the first time around, was bring in all 10 million data points, sift through all 10 million to find the 1 million relevant ones, and then start doing machine learning on that, and then go home, come back in the morning and go, okay, that one didn't work, let's try something else in terms of a model, right? But if I could say, well, I don't need those 10 million data points, I only need 10 billion, I only need the 1 million data points, I can run those models in minutes or seconds. And if I can iterate through those models way faster, I can generate the right predictive models and hand them over to my business team to execute and implement way, way faster than I could if I had to wait overnight for every cycle that I wanted to run a test on. So that's where MarkLogic really helps. It helps you slice and dice in real time right now, wrangled data that gets put into the AI system, right? So I don't have to spend time searching through my data. I mean, I literally can do a real-time query and say, okay, here's a list of IDs that I need. And then I can give it to the AI system, please grab all the data related to those IDs, right? Once I've done the machine learning, then of course, putting it back into MarkLogic is pretty easy. Lots of REST APIs, lots of ways to pump data back in. And triples tend to be a really good way of representing knowledge. So those are a pretty good way of storing the resulting stuff that you want to execute on in real time, right? So in MarkLogic 10, these two worlds are colliding a little bit, and that's pretty cool as far as I'm concerned. What we're going to show in the demo here is a pretty simple data science experiment. We have orders in the system. The orders have products, and what's interesting is each order might have 1 product, 2 products, 3 products, depending on the order that the customer made, right? Now, those orders are really not what the machine learning system needs. The machine learning needs all of the data points for a given product, right, to do its machine learning, to do predictive analytics on, hey, how much of this product am I selling the next year, the year after, and the year after that, right? So I need to slice and dice the data from the way it came in to the way the machine learning system wants to see it. And that's what we'll be showing, first of all, bringing that data set in. Then we'll show sending it to the machine learning system, and then we'll show grabbing the results and storing those in MarkLogic as well. Now, when we started looking at this problem for our customer, we said, okay, there's probably 5 different ways to do it. And we actually prototyped 4 out of the 5. And so what we're going to show you are 2 of the options that are high performing and are high throughput. And we're only going to demo 1 of them. So the first option was to actually build a Spark controller thread that would go to MarkLogic, get the sliced and diced wrangled data, and then spin off the parallel Spark jobs to do the training and testing and to create the models. And then those models would be stored back into MarkLogic, right? Now, this scales at this level, the training and test level, but it doesn't scale at this level because you really have one sort of master controller over here. What's also nice but even here, what we did is we didn't use sort of the standard REST API where we were getting small pieces of data, because you don't want small pieces of data, you want large chunks of data. We used the data movement SDK, which is meant to move large amounts of data in parallel into a controller, right? So even there, we were able to get parallelism, but it is sort of a central control system. The second one that we ran was to say, hey, we'll create a very lightweight controller, and the lightweight controller will send a set of parameters into each of the threads, and the threads themselves will be able to query MarkLogic directly and get the right pieces of data from MarkLogic in parallel and run predictions in parallel. Any questions so far? All right. The other really cool thing about what MarkLogic can do is that once you have that data, you can store it. So I can store the models, I can store the data itself, and I can store the predictions all in the same place and have real-time access to it. So it's a good place to get 360-degree views of your machine learned data as well. And with that, I'll turn it over to Bijou.
Thank you, Brian. So my name is Bijou George. I am a solutions engineer with MarkLogic. Today I'm going to show an example of still alive. Yeah, it's right. Okay. So what I've done is I have loaded some order documents into MarkLogic. Order documents into MarkLogic. Let us see what is each document look like. Each document has a set of products and their associated quantities. What I have also done is I have loaded trained machine learning models of each of this product into MarkLogic as well. With these two things, I am going to predict how much quantities of each product are required for the next 3 years. And I'm using, this is my Spark environment. This is what I will be using for the machine learning and my analytics. This is a standard out-of-the-box Spark master URL page. It is already running. It is running with 2 worker threads now. And I'm using NiFi just for controlling my flows and my jobs and things like that. Spark jobs can be controlled with various other job controllers and things like that. So I'm going to submit the Spark job here. Let's see. Yeah, the job has been submitted. It started running. So now what is happening behind the scene is the Spark job is getting the data from MarkLogic, the curated, mastered, harmonized product data. But I want you to remember one thing. What I had loaded were the order documents. It does not have the product documents there. It had the order documents had the embedded product information inside that. The API sets, the rich API set of MarkLogic and the data services approach, which is high performing, what it is doing is it is giving the data to the Spark job in the data set that is required by the machine learning job. The machine learning job actually needs the product data. It needs the data set of the product. The features required are product, which is string indexed to a number, and then the quantities and the order year. And with these 3 features, it is predicting, okay, what should be the order for quantities for the next 3 years, right? So it has been running for almost 1 minute. So let's see whether the predictions have started coming in. Yeah, it started coming in. Okay. So now the data scientist can go into the information and see the prediction document itself, what is the real output, what is the models, what is the model metadata. They can play around with different models, different algorithms, tune their models for better error coefficients and things like that, and all in the same place. They can see the raw data also in the same place, right? So if you really look at it, MarkLogic was actually the operational data hub for orders. But what it also did was it provided the aggregated data set for the data scientists in the shape that they wanted, in the shape that the data scientists wanted. Okay? And the machine learning model, the machine learning result is looped back into MarkLogic so that the data scientist has one place to see all the results. The business users use the same place to see the results. Okay. So without moving data between the operational analytic environments using expensive, slow batch jobs, MarkLogic can serve as the operational data hub as well as the data for the analytical workloads. Now, still if you look at it, actually, the Spark environment was an external environment, was not with MarkLogic. It is separate from MarkLogic. It was the APIs that were facilitating the integration. This is what is becoming more exciting in MarkLogic 10, where this is coming into MarkLogic. And that is what my colleague Yangwei will demonstrate. Thank you.
Go ahead.
Okay. Okay. Good afternoon. My name is Yang Wei. I'm a software engineer here at MarkLogic. And it's really great here to be demonstrating the new machine learning capability of the upcoming MarkLogic 10. And if anything goes wrong with the machine learning feature, you know who's responsible for it now. Okay. My demo is going to be a technical proof of concept demo. This is going to happen in this query console. It's nothing fancy, but there are two takeaway points. The first is MarkLogic. First point is MarkLogic is capable of doing this in-database machine learning. And the second point is that you can do it just like you do it in Python. So I'll be showing two examples. The first is loading and evaluating a pre-trained model in MarkLogic. So here is the X-query code. And the model we choose to demo today is a text summarization model. So what this model does is it takes as an input a long news article, and it produces a very short one-sentence summarization of this article. So since this is a live demo, everything is happening on this laptop right now. We choose to use this very short news article about an earthquake. You can see this is the input, a moderate earthquake, blah, blah, blah. And if we run this script, what's going to happen is you get the summarization of this article, or what I hoped is going to happen. So if we run, it's going to take a few seconds. During running, so you get the output there. It's a very short summarization. I think it's successful. So as you can see, the tokenization and vectorization of this input text is all happening inside MarkLogic. And then you load the pre-trained model here, this line. If you export the database, you can see the model is stored in the database as a binary file. You load this model, and you can tweak this model at this CNTK argmax to this one hot vector you get. And then you output at the end of the evaluation result of this model. So this is how you do evaluation of a pre-trained model in MarkLogic, and it's just like in Python. So the second demo I'm going to show is how to construct a model in MarkLogic and do the training inside MarkLogic. So again, since this is a live demo, we can't construct a complicated real-world model that does great things. This is just a very simple regression model that does one matrix multiplication. So just like in the evaluation case, you define some environment variables, set up the training parameters, and the only difference here is the model is no longer loaded from the database. It's constructed in the database, in this X-query script. And if of course, the training parameters. If you run this thing, the return value is the loss function, the value of the loss function. And the loss function, the value of the loss function keeps decreasing. That means this is a fairly successful training session. You can save this trained model into the database as a binary file, and you can load it later to perform evaluation, do whatever you want, and tweak it, further training it. So yeah, that's my demo today. So basically 2 points. One is MarkLogic 10 is capable of doing this, and the second point is it's just like in Python. Okay, thank you.
Okay. Let's get back into it. All right, let's summarize what we saw, and then we'll talk a little bit about the future. So with machine learning, as we are learning about everything, it's really all about the data. You know, the quality of your data is really important, and that's been true long before we were talking about machine learning. It's even more important when you're thinking about machine learning now, because the data is not only being used to run your business, it's essentially writing code for you as well. So just like you would have to understand what goes into the rules that you're writing, you need to understand what's going into your training data, you know, where it came from, are you using it fit for purpose, you know, and how it was transformed. Second, like Michelangelo, machine learning lets you uncover hidden insights. You can't write rules for everything, and there are patterns in your data that you never expected. You own all of this data already, so this knowledge is yours. Without these special tools, you'll never get access to it and be able to understand it and use it to help run your business. For data scientists, you know, MarkLogic is the best place for them to get data, because they can get the best quality data that's well understood. As Biju and Imran were showing you, by using some of MarkLogic's already existing functions, you can pare down that huge data set and get the right data to your tools at the right time in the format that they need. All of this is working together to build a smarter data hub. And Justin talked a little bit about the ways that we were doing that, you know, so applying it to your data to understand it better, applying it to the hub itself and the infrastructure to make it work better. That's what we're working on right now. Let's talk about what's next. So our plan is to expose, exploit, and enhance all of our products with machine learning. Brand new capabilities for the data hub, database performance, and service manageability all can be enhanced by using machine learning to uncover those patterns. As a part of a data science tool chain, MarkLogic is also showing to be really valuable. It's the best place for finding and managing the data that you use in a machine learning environment. With MarkLogic 10, now it can be the best place to actually run those models that you've created and become the platform where you expose that to find value, as opposed to just using it to build a model to work somewhere else. So that's all that we have right now. I think we can go and start taking some questions. Mike?
Since this processing is pretty intensive, is there going to be different kinds of evaluation nodes to do this so it doesn't impact the performance of the rest of the MarkLogic server?
So if you're using the service, then you're able to, just like you can create analytic and operational nodes. You know, there could be a concept where you can create machine learning nodes as well, as opposed to spanning them across the cluster. So it's really, the training operation is where a lot of that computation happens. You know, so that's a workload that you would need to figure out how to manage. You know, executing the models takes much less power, and it's something that we can control there a little bit easier.
And with the utilization of GPUs, does that change the pricing model?
It does not.
Okay.
You still pay per core. So now you have 29,000 cores of MarkLogic.
Well, can you talk a little bit more about at what level the integration with MarkLogic happens? For example, if I'm running a model in CNTK, would I be able to directly leverage the indices or lexicons in MarkLogic?
We can do that. As long as you can get that data from MarkLogic, you can feed that data into the model you are trying to evaluate or train.
Oh, okay, so, but I'm still trying to understand at what level is the direct integration, or it's like loading data from indices?
You need to prepare the data. If you want to use the indexes, you need to tell the model to use the indexes.
Okay. And one more question: Why CNTK versus Torch or, you know?
So
TensorFlow?
we, a few reasons for that. First, we have a really strong partnership with Microsoft. So you know they've been helping us with this integration and using this product. CNTK is actually showing to have really great performance. There are some benchmarks out there where it's actually outperformed TensorFlow and some others because of its block momentum, that compression of communication costs that I was talking about. And the third, it has a very extensive amount of C++ libraries. MarkLogic was written in C++, which makes it, you know, very easy for us to integrate that at the kernel of MarkLogic.
So you talked about machine learning and applying that to service management. Does the roadmap include recommending the addition or deletion of indexes?
Yes, that's right. Yeah, so we haven't looked at that yet, but that's definitely a possibility. So as
Awesome.
part of the query optimization, you know, finding out when queries are actually running without indexes or when a new index might help them. So that's something that we could pull from some of the meters data that we're already capturing.
When it will be released?
So the beta of MarkLogic 10 actually started on Monday. So you can contact your rep and they'll get in touch with me and we can provide you with the beta of MarkLogic 10 and we can start exploring these together. The GA for MarkLogic 10 is later in the summer, sometime the end of June.
Any other questions? Hands up.
Dumbfounded.
We're good. You were fast. Okay, thank you, everyone. Don't forget to fill out the survey, okay? And we'll see you at the party this evening. Thank you.